Good evening, everyone. I'm warmly welcome you to the Pantech Solutions, and I'm warmly welcome you for the series AI Masterclass Day 10. So, in this lecture, we are going to see about overview on different algorithms of deep learning, as well as we are going to start from designing a basic neural network. Okay, so I want to know another thing. So, how many of the people are in this now live who have registered for internship? So, if you are an internship participant, or if you are the member of 30-day challenge accepted candidates, so please type yes in the live chat. I'm going to give a little thing for you. Okay, so please type yes. So based on yes, I'm gonna give something for you. Okay, so good evening guys. So Venkata Ramesh, good evening. Prince Sony, good evening. Umesh, good evening sir. Abhay Kumar Singh, good evening. And then Harsat, good evening. Anupam, good evening. Yeah, actually we are getting a lot of yes as well as no. Type only was one yes. Okay, so don't type repeated yes. Okay, a lot of people are getting yes. Hello, Dil, hello. Okay, Deepthi, good evening. So we are getting a lot of yes response. Okay, so before that I'll make an announcement. So attendance link will be available around 8:30 p.m. So don't rush up for the attendance. Once the session is completed, still now the attendance link will be available. So you please fill up the attendance once the session is completed. Okay. So other than that, so here there is an announcement for intern candidates. Okay. So details waiting for you out there in internship portal, because this session for while doing a recording for internship portal, it up to 1 hour and 20 minutes. So since this YouTubers for only 1 hour, so we have shorted out a little content. Okay, so if you are an internship candidate, please go there. Okay, so there I have already launched that files and video tutorials. So please you have a benefit. So this is an optional, you can check it out, as well as if you want you can go there in internship portal, because that is 1 hour and 20 minutes video. I have explained a lot more in detail. Okay, so that's the surprise for you. I hope you like it. If you like it, please type like it in the live chat. Okay, so we are into the session. So these are the yesterday's missing part. So first of all, I would like to say sorry on the previous session's technical issue. Okay, so these are the slides. So I hope you have installed this TensorFlow, and then Keras, and then Pandas, and then SciPy, and then Torch. So I hope you have installed. So these commands which I have already given in the description of yesterday's session. Okay, so so that's it. So Anupam, no work, so like to attend both. Really great, really great response. So a lot of people are saying like it. Great. Good evening guys. Really I feel very happy. So we'll move on to the session, guys. So in this agenda, we are going to see about the first neural network, and about a perceptron. So what is meant by perceptron and those things. And we are going to move on to deep learning algorithm, about like a overview of this algorithm and what are the types. And then we are going to specifically we are going to have a detail about CNN and CNN architecture, since CNN is more popular and is greater than artificial neural network. So we are going to see that. And then we are going to implement a neural network. Okay, like we are going to have that implementation part by seeing some kind of syntax, as well as some kind of issues while facing neural network design. And then finally we are going to design a neural network based application for PIMA Indians diabetes classification. Okay, so this is the thing which we are going to see in this session. Okay, so a lot of people have liked that, Sarvan and Rekha Meena, and a lot of people have liked it. Kailash, great guys, great. So so that's it. So we are move on. So first of all, about a neural network. So we have already discussed about it, right? So neural network, like interconnection of input as well as output with associated weights. So associated weights in the sense the lines or which is connected between each and every neuron. So that is kind of like random assigned values, which is known as weights. Okay, so on the deep learning process, while doing a training, it will adjust automatically. Okay, so it will adjust automatically to have a better classification or better training rate. Okay, so that is a normal neural network. but I hope you all heard about the word called perceptron. So what is meant by perceptron? So before that, in the neural network, it already contains that layers. So first one is input layer, and in intermediate it has an hidden layers. So hidden layers in the sense any kind of convolutional or like lot of max pooling or lot of layers are there. So those are all hidden layers, and at the final state we are going to have output layer. But what is the perceptron means? Without a hidden layer, if I am going to have only input layer as well as only output layer, means that is known as a perceptron. I hope you got it right. So that is a difference between these two. Okay, so in that network, so input and then hidden and then output means normal neural network. But while talking about a perceptron in specific, that means that without any hidden layers, so input and then output layer, okay, which will be very helpful for to make a basic and quick decision. So for example, let us take a temperature values. So we are going to train it with any algorithm. On that scenario, so if the temperature is greater than 100, that is fever. If it is less than 100, that is normal, right? So on that scenario, if you want to deploy in depth on data set which we are going to provide, so on that scenario we'll use the perceptron. Okay, so for perceptron also we are going to see an example. Okay, so and then while talking about the deep learning algorithm, I hope a lot of people have heard about it. That is artificial neural network (ANN) and recurrent neural network (RNN), and finally convolutional neural network (CNN). Okay, so on that, so first of all about artificial neural network. Okay, so let us take same kind of neural network design. Okay, since this neural network which contains the activation function at the final state, before itself we have seen what are the activation function, right? So on that activation function, with the help of that activation function, the neural network or the system can able to handle the non-linear functions. Okay, only if it contains the activation function. If it doesn't has, it can't able to handle the non-linear function. Okay, so that's it. And then here for example, the output of a single layer or the output of each neuron you can take. So for example, these circles, no, so these circles are neurons. So each and every neurons, the output, okay, so the output of the each neuron is the activation of weighted sum of an input. So here there are weights. Okay, so weighted sum of inputs is going to fed as an input to the further neuron or further layer. Okay, so which can able to handle the non-linearity function with the help of activation function. Okay, so and then while talking about the feed forward neural network specifically, that input processing and each and everything will be in a single direction. It won't look back for the values which we got in the previous output or previous layers. So it won't look back. Okay, so that is completely on feed forward neural network. Okay, so and then another thing which I have to say is like while hidden layers, so number of hidden layers is more than one. So that is known as deep neural network, that is DNN. Okay, so that's it. And then while talking about recurrent neural network, so in the diagram you can able to see the difference. So it is completely on feed forward, but it has some kind of backward arrows are there, right? So on that arrow, nothing but looping system in a hidden layer of artificial neural network is a recurrent neural network. Okay, so it also captures a sequential information of a input data. So the best example is let us take voice based application or chatbot based application. Okay, so I'm going to question my robot, what is your name? Okay, so I'm going to ask a question, what is your name? Okay, so that's the question. So this going to process from neural or network or layer to layer. Okay, so on that scenario, if it recognize that what is the name, what's your name? Okay, so it just identified a name or what is, okay, let us assume, so it will identify the your name. Okay, so that is incomplete sentence. Okay, so on that scenario, it should be able to predict the previous value or previous word or previous sentence to make it to be form as a single sentence. Okay, so like it is like kind of predicting the nearby values. So like what is your, so what are the suggestions, name or mostly on name, right? So like kind of prediction should be done with the help of analyzing the previous value which it got in the previous layer. Okay, so like that kind of known as that sequential. Okay, so and then this RNN shares parameter across different time steps. So like it will process parameter in here and then another layer and further layers. And this common recurrent layers which also uses LSTM. So what is meant by LSTM? That is long short term memory. and GRU means graded recurrent units. So what is mean by those? Why we are using, or why we are to learn this LSTM? Because while passing from each and every layer, there are a lot of difficulties we'll face. Difficulties such as like explosion of the gradient. Okay, so that kind of scenario, with the help of this long short-term memory, it will have the memory of previous output, so that it will find the difference between the both values. So like a predicted output as well as the target output. So it will have the comparison, and it will try to estimate the proper value or optimized value to have a proper neural network. Okay, so that's the purpose of using LSTM. And the GRU means, so it will have that like kind of flow control. So like to have how much data, how much data or information should pass through each and every layer. It will have that flow control. If there is a more bunch of data is entering into it, so on the time we may have a lot of problems. So that GRU will have that control of flow of data, okay, between neural networks. Okay, so and then especially this recurrent neural network will be helpful in natural language processing. So like chatbots or your voice assistants or your Google search engines or SEO, that is search engine optimization in Google, or those kind of services or those kind of prediction which require to predict the sentence which is based on the previous sentence. So that's the right meaning. So predicting the upcoming sentence by identifying or by studying the previous sentence. Like it will have that sequential information or sequential study of the data. Okay, so that kind of time, so we'll use this recurrent neural network. Okay, so okay, some people are saying to go slow. Actually this is 1 hour and 20 minutes, guys, so we need to have a little rush up. Okay, so okay, that's okay, I'll try to go slow. So and then while talking about a convolutional neural network, okay, so while talking about a convolutional neural network, it is advanced than artificial neural network, and it also learns to design a filter automatically to extract the feature automatically. Okay, so we have already told you there are hidden layers. There will be a lot of hidden layers. So each and every hidden layer, it should find that specific filter to extract specific features. Okay, so and then it also captures the spatial features, that is kind of arrangement of pixels. So for example, let us take this object. Okay, don't think this is an object, this is an image. Okay, let us take this is an image. Okay, so in this image it has the pixel arrangement. Like if I am converting that into a matrices, so it contains that pixels, right? So nothing but the pixels. So we will have that this convolutional neural network will process this image in the form of pixel or arrangement of pixels, like one row and then second row and then third row, or batch by batch. So that kind of process, or that known as spatial features. Okay, but whereas the artificial neural network won't do that. Okay, so and then also this convolutional neural network follows parameter sharing like RNN, like following up the parameters. So like this is the value of the current output. So this is the predicted output. Like that, it will have that parameter sharing between it. Okay, whereas this artificial neural network won't do that. And this also contains a convolutional neural network design instead of having the recurrent neural network design. Okay, we'll see that design in the upcoming video or upcoming slide. Okay. So and then in this convolutional neural network, convolution and pooling function are used as activation functions. So for example, what is mean by, you can ask, what is mean by convolution layer or pooling activation functions? So we'll see. So what does mean by convolution means? So let us take a same image. So don't think this is an object, take as an image. Okay. So let us take an image. Okay. So it will take this image and then it will apply the filter for this image. Okay, so it will take this is a input image. With that, it will take or it will apply the filter of an image, and it will process this two part, like non-filtered one and then filtered one. So filtered one is known as kernel. So it will process these two image to give you the output image. Okay, so that is the work, or that is the function of convolution layer or convolutional activation function. Okay, but while talking about a pooling, what is mean by, or what is the work of pooling layer? But here we have already discussed that convolution will take this input image and it will apply filter for that input image, and it will process the two image to give an output. But while taking a pooling, it will take a same image, but instead of applying filter to that same image, it will take the maximum value. Okay, so if it takes the maximum value and it is giving to the, or it is processing that maximum value to the upcoming layers of neurons, so that is known as maximum pooling. If it takes minimum value instead of taking a maximum value, that pooling is known as a minimum pooling. Okay, so I hope you all got it. What is about a basic? If yes, please type in your live chat. Okay, so a lot of people are already told okay and then yes. Okay, so I hope you all understand about basic algorithm design. Okay, now we are going to see in depth of convolutional neural network architecture. Okay, so let us see the architecture. Okay, click. Okay, so here we have this convolutional neural network architecture. Okay, so is it looks so very difficult? Actually not, it is very easy guys. So I'll tell you as much it is understandable. Okay, so here we have this convolutional neural network architecture. So let us take a basic concept. Okay, a lot of people are telling us programmer Arnab, Yukti, Prakash, Amarnath, Lokesh, Deepali, Pavan, great guys, great. So here let us take this CNN architecture. So let us take a basic neural network. How it will be? So in first point it will have the input layer, and finally it will have the output layer. On intermediate it contains the hidden layer, right? So here let us take what is the input layer, that image which are given there. So that is number 2, that is an image. Let us take that is an image, that handwritten, this is for handwritten recognition of digits. Okay, so like a 0 to 9. Okay, so digit classification of handwritten image. So here we have given the number 2 image. Okay, so that is the input layer. On the output layer there are some circles. What are the circles? That is nothing but a neurons, right? So here we are going to classify digits, right? So on the digit part, so we have up to 9 or 0 to 9, that is up to 10 neurons in the output layer. Okay, so in the input layer we are going to feed one image, so that is input, and then the final, that is in output layer, it contains 10 neurons. Each neuron represent each digit. So like for example, first neuron represent number 0, second neuron represent number 1, third neuron represent number 2. So likewise it represent up to 9. So okay, like digit means 0 to 9, that's enough, right? We don't need to recognize 10 or 11 or 12, it is not necessary. So 0 to 9 is enough. Okay, so that's why in the final layer or in the output layer it contains 10 neurons. So each and every neuron represent each and every digit. Okay, so let us take the hidden layers now. Okay, so on the hidden layer what we did, so let us take the same input image. So let us assume here 2 is written. Okay, so this is present in the left side, that is in the input layer. Okay, now this image or this image going to pass over from each and every layers in the hidden layers, and finally it's going to reach the output layer. Okay, so in the input layer, so it's going to pass over towards each and every layers. Okay, so here we have designed one neural network, that is especially on convolutional neural network. Okay, so for example, the first layer, what is the first layer we have specified here? That is convolutional layer. Okay, so and by following up the convolutional layer we have designed a maximum pooling layer. Okay, so this is the first convolutional layer and this is the first maximum pooling layer, and then we are assigning or we are going towards another convolutional layer, that is second convolutional layer and second maximum pooling layer, to segregate a lot of digits, or to extract lot of character, you can say. So okay, so for example, let us take number digit 2. Okay, so let us take number digit 2. Okay, so but that 2 has that curvy line, right? So that curve is there in the 2, right? So let us take another character, another handwritten recognition of number 1. Okay, so let us see the number 1. Okay, so on the number 1 it doesn't has that curve or anything in it, right? So let us take another digit called the number 3. So number 3, let us see number 3 and number 2. It has that curvy part or curvy structure which is similar to 2 and 3, but that is not equal, but both has some similar properties of that curvy part. Okay, and then again if I take number 5. Okay, so number 5 is also having downside, it is having the same that curvy part as like a 3, right? It has lot of similarities between each and every digit, right? So on that scenario, the single layer or single perceptron is not enough for classifying a digit, or you can say it can be, but it won't be that much accurate. So on that scenario, we need to create multiple hidden layers. So inside the hidden layer, we need to add a lot of layers to extract lot of features. Okay, so a lot of features in the sense, here we have first convolutional layer, and then first maximum pooling layer, and then second convolutional layer, and then second maximum pooling layer. Okay, and then fully connected layers. Okay, so and another main thing is, so each and every layer will have some prerequisites. So for example, let us take this layer, this first convolutional layer, it has that 24 cross 24. So here that represent like some kind of 5 cross 5, right? So that we'll see in the upcoming slide. Okay, so each and every layer will have some kind of prerequisite. So for example, input image should be like this in the format, like 28 cross 28 means 28 cross 28. Okay, so like that everything will have that kind of area. So here each and every image is not processed as a single image, so it contains some kind of batch. So from that batch it will apply that convolutional process. So convolutional in the sense to apply the filter on that image and giving or combining both input to give an output. On that output maximum pooling image which we got, so on that again it will take some batch. So on that batch it will apply the maximum pooling. So maximum pooling like finding out the maximum value of that certain batch, and then again that value will be passed over to the another layer. So like that each and every layer it will get passed over, and it will identify the neural net the features. Okay, so at the final state it contains the flattening. So we'll tell you what is meant by flattening. Okay, so other than that each and every layers will be connected to each and every neurons at the final state. Okay, so on the final area we'll have fully connected layers with the activation function of ReLU. So other than that we'll have this final 10 neurons. Okay, so neurons means, so here we have 10 neurons. Okay, so 10 neurons in the sense 0, 1 or 2 or 3, like 4, and then up to 9 we'll have that 10 neurons. Okay, so final state, everything is connected to each and every layers. Okay, so and after that at the final state only one neuron going to be activated based on the gradient value or any value, but at the final stage only one value going to be activated. So for that only one value, so for example let us take what is the number of neuron going to be activated here. So here the third neuron going to be activated here, because the number or digit which we are given is number 2. If the convolution in a neural network work properly, that third neurons, so that is 0, 1 and then second, so that is, this is up to third neuron going to be activated to represent the given image is the digit number 2. Okay, so that's it. Okay, so the likewise each and every images or the single image going to be processed towards each and every layer to identify or to extract the features common between that. Okay, so that's it. And then we hope all know what about the softmax classification, which we are going to use at the final state of normal neural network, right? So yesterday itself we have seen that formula is equal to softmax is equal to exponential of ln divided by modulus of ln, modulus of exponential of ln. So what is meant by ln? So L is equal to x dot w plus b. So definitely you will ask lot of questions. What is x, what is w, and what is b, right? So we'll say what are those. Okay, so first of all we'll take x dot w plus b. Okay, so first of all we'll take x. So before that we'll see this one. Okay, so simply I'm going to take one image. Okay, so on that image it is converted into matrix, that is 28 cross 28. Okay, since it is not a color image, it is binary image, so 28 cross 28 cross 1. Okay, so let us take this image. Okay, so let us assume this is an image. Okay, so okay, a lot of people some people are saying fast. Okay, I'll try to go slow further. Okay, so let us take this image. Okay, so in this image let us take this image going to be 28 cross 28, that is nothing but 28 rows and then 28 columns. Okay, so 28 rows and 28 columns, this is completely a matrix. Okay, so on that matrix what we are going to do, the flattening process. So this flattening process which we have done in the last of fully connected layers on the convolutional neural network. So flattening, what it means like, so we'll already have 28 cross 28 matrix, like 28 rows and then 28 columns. Okay, so let us assume this is number 2. Okay, so 28 rows is there, so as well as 28 columns are there. Okay, so on that time, what we are going to do, first of all, flattening is nothing but, first of all, it will take the first row, that is 28. Okay, and then again it will take the second row, that is 28. Okay, and it will take the second row and it will append here, and then it will take the third row and it will append here, and then append, and they'll the final state of this flattening process. So this complete one image which has 28 cross 28 matrix, that is rows, 28 rows and then 28 columns, into a single matrix or a single row. Okay, by appending each and every row with the another row, so it will be appended and it will be flattened. Okay, so on that flattening, definitely what is the matrix value? So that is 1 cross 784. Okay, so 28 multiples of 28, what does mean? That is 784. Okay, so like a complete the square image going to be converted into a single flattening pixel area. Okay, so that is nothing but here squares are there, so don't count the squares, it is not match it with. Okay, so let us assume 28 cross 28, that is 784 squares are there. Okay, so this image, so first of all it will take the first row and then it will take the second row and it will append here, and then third row it will be append here. Okay, like that it will take an append. Okay, so so here what this 28 cross 28 resembles, this is an example guys. So let us take one image which has the matrix of 28 cross 28 pixels. Cross 1 resembles that, this is a binary image. Okay, so if it is color means we'll use RGB color codes. On the time 28 cross 3. Okay, so here we are going to use only we are not going to use a color image. Okay, so that's why this 28 cross 28 just a kind of size. Okay, so we have flattened it. So each and every pixel of 784 pixels going to be connected with each and every neuron at the final state or output layer. Okay, so for example here one pixel is there, so first pixel, so that will be connected to 0 and 1 as well as 2 as well as 3 as well as 4 as well as up to 9. So it will be connected with 10 neurons at the final output network. Okay, so each and every pixel which is present or which is flattened here going to be connected with each and every neurons at the final output layer. Okay, so that's it. It is going to be connected with each and every neurons. Okay, so now we'll see that formula. Okay, so what's the formula here? So that is L is equal to x dot w plus b. Okay, so what is mean by x? X is nothing but an input image. Okay, so it going to be connected or it going to be flattened and it going to be connected with the final state of neurons. So that on that we are going to have a set of random assigned weight values. Okay, weights is like kind of lines which is passing over from pixel to the neurons. Okay, so here so that w which resembles that weights. Okay, so this flattened image, so let us take this is completely a 784 pixel flattened one. So that flattened one going to be connected with the final neurons with having some kind of weights. Okay, so formula is to have a product of input image with the weights. Okay, and we are going to add the biases. So you may ask why we are going for adding a biases. So why we are doing that? So for example, if we take some kind of area or some kind of process, so on that process like it may have some kind of losses. So for example, let us take an input image. So on that image, if the matrix value of the pixel value, if let us take that is a 0. Okay, so let us take the value or the input image going to be 0. Okay, so what is the product of 0? So anything, if you are doing some kind of dot product with any weights or randomly assigned values, anything, but the output going to be 0. If the output is 0, then softmax of 0 is not helpful to do the training. Okay, so that's why we are doing a bias. We are having addition of biases. Okay, so to overcome that kind of issues. Okay, so even if the input or thing which is processing it through, even if it is 0, even though with the help of the biases, that complete term won't turn into 0. Okay, so that's the main thing. Okay, so softmax. So this is the formula. So after completing or after applying the softmax function of x dot w plus b, so it will give you the prediction. So you can ask what is the softmax will do. This is completely on detailed expansion of different differentiation. So a lot of mathematics formula will be there. That this is within 1 hour. It is not enough for that. Okay, so this softmax. So you don't bother about it. Why? Because this softmax is already written in a sort of function of TensorFlow as well as in a Keras. Okay, you can use that library to do this kind of softmax. You want to do only you have to initialize only what is x and what is w and what is b. Okay, so the final output of the softmax function going to be the predictions. So 10 neurons will be there. So on the 10 neurons, what going to be the predictions? Okay, so that's the output of it. So I hope you all remember the formula, the product of x and w. What is meant by x? X is the input image, w is all the weights, and b is all the biases. Okay, so we'll see what are those in detail. Okay, so for example, here we have done it for only a single image. So single image which contains the 28 cross 28. Okay, so but let us take 100 image at a time. So we have already assumed that this is a single image, right? So 28 cross 28. So now let us assume. So I'm going to have this kind of same image for 100. Same, not a same image. I'm going to have 100 images. Okay, so like 1, 2, 3, 4. Like we are going to have 100 images. So we already did that. We need to do that flattening. So on that flattening, so single image with the 28 cross 28 going to be converted into a single flattened structure of 1 cross 784, right, for a single image. So and then what we are going to do, we are going to have that for 100 images. So one image is already flattened into 1 cross 784, as same as like for 100 images. So 100 cross 784. This complete part going to be x. Okay, so x is means, so each and every image is going to be flattened to form as a single batch, so which contains 784 pixel values. But for 100 images, the term which resembles that matrix of 100 cross 784. Okay, so 100 cross 784 matrix going to be there in the value of x. Okay, now what we are going to do, we are going to have a weights. Okay, so let us see this neural network. So each and every 784 going to be connected with only 10 neurons, right? Only 10 neurons in the final layer, not more than that, right? So on that time, so what weight is responsible? So x for connections is like each and every lines, right? So for 1 pixel, it's going to connect with 10 neurons, so 10 lines, right? So for 10 neurons. Okay, so on the time, so what are the weights going to be? So W00 means the first pixel we are going to connect with the 0th neuron. Okay, so same as like for 784. So from the starting from 0, it have rows about 783. So totally 784 values. Okay, so 784 lines going to be there, right? So from each and every pixels. So 784 lines going to be there. So that is weights. So that going to be connected with only the 10 neurons. So what going to be the matrix? So W00, W01, W02, likewise up to W0 to 9. Okay, so up to, but rows it contains 783 or completely on 784. Okay, so what going to be the matrix of matrix size? That going to be 784 cross 10 matrix. So what are that matrix is means, that is W. Okay, so what we need to apply, we need to do the matrix multiplication of x and then W. Alright, so here already which is x is there, so we are going to do the matrix multiplication with the W. Okay, so let us take this first matrix, that is 100 cross 784, and then weights 784 cross 10. So while doing matrix multiplication, 784 got cancelled. So what going to be the final matrix? 100 cross 10, right? So that going to be the final matrix. Okay, so same as like we are going to do the dot product, so we'll get the output like which is described in here. Okay, so the product of the input image and its weights, which going to give the matrix with the size of 100 cross 10, whereas the input size is 100 cross 784. We are going to process a 100 image. Okay, so this is going to be one matrix. Okay, so on that matrix we are going to add the biases. So biases is for additional purpose. So biases is for each and every neuron which is present in the final layer. So that is 10 neurons. So 10 biases we are going to add it up with. Okay, so this is overall thing. So on that overall thing we are going to get the output of predictions. Okay, so here I am going to show in the term of TensorFlow. Okay, so here in the TensorFlow, how we can use the softmax function. Okay, so you can use the syntax called tf.nn.softmax of tf.matrix multiplication of x comma w plus b. So what is mean by x? That is 100 cross 784 matrix of input image, input of 100 images. And then what is mean by w? W means w of 784 cross 10. Okay, so what is mean by b? B means b of 10, so that is biases. So we are going to directly pass into the softmax function simply. So it will do every mathematical operation automatically. Okay, you don't want to bother about the matrix or mathematics, we have to study that math, don't bother about it. Okay, we need to pass only the argument, so it will do each and every process of that working flow. Okay, so and then so predicted output is y of 100 cross 10, so don't think about it. So here, so the output is computed probability. So like I already told you, at the final state of the layer we are going to have the output, or we are going to have only one activated neuron, right? So on that scenario, let us take, or let us think this is a neuron, these are the neurons. So first it will have 0.1, that is computed probability, 0.1 or 0.2, 0.9, 0.5, 0.3, 0.1, so likewise each and every neuron contains final value. So on that final value, which one has a maximum value? That is for number 2. So the actual probability, what are those? So whenever which one is greater, so that one it turn to 1, so other neurons get triggered to 0, so that 1, so 1 resembles that, that's going to be the activated neurons. So from that we can able to identify the class. So the image which we are given in the testing time, so that digit is going to be number 2. Okay, so these are the workflow of how it going to classify and how it going to recognize characters. Okay, so and then we are moving on to the basic syntax. So we already know to design a neural network we need to add furthermore layers. Okay, so here this syntax is for using keras. Okay, so if you want to add some kind of layers, so we need to pass the layer name. So it may be convolutional or it may be dense or anything. Okay, so here we are deploying ANN. Okay, so dense of 12 comma input dimension is equal to 8. What are those? So if you see this image, you can able to understand. So already we have input. So input dimension is equal to 8. So how much input part or input image area there? Let's say it based on classes or anything. Okay, so we have that input, and then in intermediate it has an hidden layer. So that layer is first one, model.add of dense of 12. So how many neurons should be there? So 12 neurons will be there. Okay, so on the 12 neurons, so we have specified the activation function of ReLU. Okay, so we have declared it. Okay, so declared one hidden layers. Okay, so it will be connected with it. So other than that, if you want to add another layer, so again we are going to use another syntax called model.add of dense of 8. So 8 means 8 here 8 neurons. So it will here also we are going to initialize with the activation function of ReLU. So don't bother about further activation functions. We will discuss in detail on the upcoming sessions. Okay, so we are going to add the another layer. So here we have added 2 layers. Okay, so at the final have there may be multiple classes. Don't think only one neurons is there. So it may be multiple. Okay, so that's it. And then we need to initialize for compilation. Compilation is for to optimize the neural network. Okay, so how it should have an optimization? Is it based on accuracy or is based on loss? So definitely going to be accuracy based optimization. So here we are going to pass 3 arguments: optimizer, loss function, and list of matrices. So on that this optimization or these things should be done based on the accuracy. So matrices accuracy. Okay, we need to declare that. So this model will be compiled based on this kind of optimization settings. Okay, so this is basic syntax. And another thing you have to know is batch versus epoch. So what is mean by batch versus epoch? So for example, training occurs over the epoch and each epoch is split into batches. So for example, while doing a processing, so let us take an image. So on that image, if I have 100 images while doing a training, okay, 100 images means, So it will process each and every image one by one, right? So for one iteration means, so it looked for 100 images once time, and then second iteration for 100 image, and third iteration for again 100 image. So processing of 100 images completely, that is one iteration. That iteration is known as epoch. Okay, so and then further certain image, even while processing into a single image, so by processing in a single image, we need to assign a batch sizes, like looking for a certain part of an image. Okay, while talking about the batch size, so if you are having very poor PC or laptop, so on the time batch size should be little bit less. Okay, so if the batch size is 128 or like if it is greater, definitely you will get a error called some kind of memory error. Okay, so already epoch, so epoch will consume more time. So epoch if you are dropped 150 epoch, so for 150 times it will process each and every complete data set which we are giving. Okay, so that it will have the improvement in that accuracy. Okay, if you give only 5 epoch, definitely the accuracy won't be good. Okay, so on that scenario we need to drop more number of epoch to have more classifications. Okay, so like more accuracy. Okay, so other than that, this batch will be helpful to process a single image, like how much part you should process. Okay, so on the time, so already if you have changed the epoch value into more value, like 150 epoch means, so definitely system will take time to complete each and every epoch. But other than that, if you are getting some kind of error, like any memory issues, so on the time the error will be on the batch size. It can't able to handle that much memory or that much computational power. Okay, so on the time you have to try to reduce the batch size. Okay, if it is 128 means you try to put 64 or 32 or 8 or anything, you just try to reduce it. Okay, so that you won't get that error called memory or any kind of error regarding that computational power. Okay, so that is epoch and batch. So and then saving and loading model, this is a very main syntax which we are going to see. Okay, so for example, save and load model. So why we are going for saving and loading model? So let us take an assumption. So I'm going to process 100 data, like 150 epoch. Okay, so it took up to 30 minutes. Okay, so I'm going to do the training for 30 minutes on the same code. If I write the code for doing a recognition or doing a classification. Okay, so at the first iteration it will do the classification and it will display you the output. But again, if you want to try that trained model, again if you want to begin the code means, so definitely it will start the training process again for 30 minutes. That is unnecessary work, right? So on that scenario, what we are going to do with the help of Keras saving syntax, we are going to save the trained model in our local directory. Okay, so let us see first saving model. So Keras model can be saved in the format of .json format. So with the help of this syntax, we are going to serialize the model file and to be saved it in the format of .json. Okay, so the JSON is kind of dictionary format. Okay, and then we are going to save the weights file in the format of .h file. So .h file is also another kind of extension which will be helpful to save the weights of your model. Okay, so model will be saved in the the core model file or model data will be saved in the format of .json, and the weight specially will be saved in the extension called .h file. Okay, so and then loading model. So once the training is completed and it is saved in your local directory, we have to load that model for our recognition part. So training and then testing. Okay, so on the testing part we need to load that model. Okay, so same as like with the syntax called open of model.json of R. So here it represents W. W means writing, right? So R means reading. So reading the JSON format or JSON file. So JSON file.read resembles that we are going to read it and we have to close that JSON file which we have opened in the first line, and then we are going to load the model and its weights. Okay, so we are going to load the model and model file and then weights, so to save it in a certain variable so that we can use that model file for further application. Okay, so definitely you no need to train each and every time. So that's the main thing which we have to learn. So whatever the neural network we are going to design, you just please save that neural network model in your local directory. So like if you are training with a different CNN, so you can say that the model file in CNN first try dot model, CNN first try dot h file. So and you just change any other parameter and try to run the code and observe the accuracy. So that is saved in the different model. So it will be very better, right? So for each and every models you can change that parameter and you just change it so that you will know. So at final stage you have that evaluation like which model is good. So on the time you just choose the model and just use for your application. That will be very perfect way to handle on deep learning and machine learning even. Okay, so I hope you all got it, right? Okay, so we are in the practical session. Okay, so I have already told you with the help of that data set which we are going to process for the diabetic detection. So before that we'll see that data set. Okay, Pima Indians diabetes. Okay, so this is basic code which I've took from another. So this is like a kind of some kind of columns are there. So 6, 148, 72, 35, 0, 33. So some values are there. We don't know what are those, right? So this is based on for diabetic detection. So at the final layer, just remember. So this is for presence or absence. So presence of diabetes means, so that is 1. Absence means that is 0. Okay. So first of all, I'll show what are all those other 8 columns or those things. So first of all, I'll open the code. File and then recent files. So I'm going to choose the training. Okay, so here this 1 2 3 4 5 6 7 8. So I have already told you, so to comment some syntax you can give hash symbol. So other than that, other way to do the comment is putting like 3 single quotes here. Okay, so it will also be commented, so it will be hidden. Okay, so here each and every one represent number of time pregnant or plasma glucose concentration. This will happen for usually for women. Okay, so and then age and then class variables. So 1 2 3 represent the column numbers. Okay, so let us see here. So 1 2 3 4 5 6 7 8 and then 9. Okay, so 9 columns are there, but only that 8 column represent the value or the training parameter. Okay, but at the final layer or a final column is represent the class. Okay, so let us assume if the value is 6 and then if the age is 50 and if the other parameters are these value, it represent that patient has that diabetes. Okay, so likewise we'll use that kind of format. Okay, so here there are those. So we are going to identify what kind of we are going to pass some kind of other inputs. So from this Excel itself, and we are going to identify either the value which is present in here, either that person going to be or diabetic occurred patient or not. Okay, so that's it. So just for a comment, just for reference guys, so don't think that is a code that is not executable one. Okay, so first library. So from NumPy import load text. Actually this Excel file, no, so Excel file can be loaded in many ways, like like you can use a library called import CSV. So with the help of that import CSV also you can able to read that Excel file. So other than that, with the help of NumPy to convert that into array or like kind of list, so we can use this NumPy also with the help of load syntax. So from NumPy we are importing a load text. Okay, so that is one syntax to which will be helpful to process .csv file which is present in our local directory. Okay, so and then in the Keras library we need to learn some kind of thing. So Keras.models and Keras.layers. So okay, first in this project you just learn that one only. Okay, so we'll go step by step. Okay, if I said what are all every option which is present in Keras means, so that will be little confusing. So we'll learn as bit by bit. Okay, so that's why we didn't cover little bit of activation functions like ReLU. So that's why like we are going to learn as step by step. Okay, so Keras.models. Okay, so from Keras.models import sequential. So if you are handling kind of model kind of application in a Keras, we need to import from Keras.models. Okay, so and then import sequential. So sequential is kind of empty stack. So empty stack means empty neural network layer, where we are going to design our own neural network from the scratch. You may ask, is there any option without creating a neural network from the scratch? Yes. Tomorrow we are going to see that, like using a pre-trained model from the Keras or any other library. We are going to use a pre-trained model. From the pre-trained model, we are going to customize some kind of thing, or we are going to do some kind of recognition from the pre-trained model. Okay, so that is another option. Okay, so here we have initialized as a sequential. So with the help of sequential, we can able to design a neural network from the scratch. Okay, so we have initialized the sequential, and then keras dot layers. So layers we have already seen. So we need to design a layers. So if you need dense net layer, we have to specify as a dense. If you need like pooling means, so we need to define that layer. So we need to call based on the layers which require. Okay, so keras.layer import dense, and then again keras.models import model from JSON. So this will be helpful to save the model in the format of JSON. So that's why we require this library keras.models. So I hope you got this libraries. Okay, I hope you understand this import libraries. So if yes, please type yes in your lecture. Okay, so and then data set is equal to, with the help of this load text syntax, I am going to load this CSV file. I am just assigning its name, and then delimiter is equal to comma. So comma, which is nothing but let us take one string. Okay, so hi comma hello. So what is the delimiter? That is comma. So the certain keyword or certain symbol which is separating one word from another, that is delimiter. Okay, so for example, if this is one, if this is the word, so what is the delimiter? That is space. What is the delimiter here? That is dollar. Okay, so in the Excel sheet, while reading from the syntax of load text, we need to specify what delimiter it is. It can be able to segregate between two words. Okay, so a lot of people are saying yes. Thank you guys, I'm really happy. So we have specified as a delimiter to segregate each and every columns. So okay, so that first column which is represent, and then second value is segregated with the comma, then third comma, fourth comma, like that up to 9 values. Okay, so on that delimiter, which is assigned as a variable called data set. Okay, so on that we need to get what are the first part, like train parameter. Okay, so we just assigning as a x and then y. So x is colon comma 0 to 8. So like it will start from 0 to 8. So let us print x and we'll check. Okay, so print of, it's getting late, right? Okay, so it's of x. I'll comment the rest of the part. Okay, so and then run module. So it is taking some time to load that file which is present in that CSV file. Okay, great. Still now a lot of people are saying yes. Great guys, really great. So it is taking some time, so let us take. Okay, so here we are taking that x value and then y value. Okay, so if you take especially on 8 means, so 0 to 8, that is up to 9 columns are there. So that 8, that final column, it represent that y, and then other rest of the things it represent as a x. Okay, so other than that, here we are going to start that sequential. Okay, so like we are going to design our neural network. So basic neural network. It is going to be very easy when compared to other. Okay, so let us take here. So I'll remove this comment to show you. And while explaining the code, don't see the further lines, guys. Why? Because please follow my like my highlights. Okay, so it will be very helpful. Okay, so here it is printed. Okay, so what is x? So here it represents 6, 148, 72, 33.6, 0.627 and 50. There is no another thing here. So we'll see, compare it with this Excel file. So 6, 148, 72, 6, 148, 72, 33.6 and 0.627 and 50. So which is present here. Okay, so this is up to that first row. Okay, so like it will take each and every row and it will get appended as a single array. Okay, so that's it. So now I am going to start from the sequential or we are going to start the neural network from the scratch. So model is equal to sequential. So we are going to insert or initialize as a empty stack, and then a model dot add of dense of 12, the same syntax which we have seen before. Okay, so we have initialized this three layers. Okay, so dense of 12 and then dense of 8 and then 1. So finally we have initialized the activation function of sigmoid. So I hope you all know what is the function of sigmoid, which is going to give the probability distribution, like in which neuron is the proper neuron for that. Okay, so that's the process. And then if you want to display the structure of your model, you can use the syntax called model.summary. Okay, So I'll comment to the further syntax, run and then run module. Okay, so if you see here, model is sequential and it is displaying my layer or my layer format. So first of all, it has densenet 12 and then 8 and then 1. So it has totally training parameter of 221. Training parameter is 221 and non-trainable parameter is 0. That is nothing but valid data or valid parameters. Okay, so that's it up to here. So we'll remove other comment. Okay, so here now we need to do the compilation for better optimizing of neural network, or to better optimizing the weights which is present there. Okay, so this syntax we have already seen. And another thing, main syntax, model.fit of x comma y. So x represents that input data, y resembles that output class which is going to be, and we have initialized the epoch into 150. I can't do 150 epoch now because it will take, definitely going to take more time. Okay, so I have initialized as epoch is equal to 5, so 5 epoch, so definitely accuracy will be very less. Okay, so I have initialized the batch size is equal to 10. Okay, so definitely for this batch size 10, it won't give you the error. Okay, so that's it. So this model.fit will do the training process. So it will do the first iteration, that is epoch 1, and it will give you the accuracy and then loss. And then second iteration, that is second epoch, it will give you the accuracy and then loss. So like that, it will give accuracy and the loss for each and every epoch. Okay, and then other syntax which is model.evaluate. So what is meant by evaluate is overall accuracy. So what is the difference between model.fit and model.evaluate? Model.fit will give you the each and accuracy and the loss of each and every iteration, or each and every kind of each and every epoch, it will give you the accuracy chart. But this model.evaluate will give you the overall accuracy. Okay, so on that accuracy, we are going to print that accuracy in the format of %2f, that is like kind of float. So and then accuracy %100, so it's going to give it in a percentage. Okay, so and then as we seen in the syntax, same syntax before, so model.to.json, we are going to convert into JSON format, and we are going to save the weights file in the model.h file. Okay, so that's the code. It's very simple, right? So this is the same code which we are going to see in the upcoming session to design a neural network by having different layers, and for color image we need to design neural network at a different way. Okay, so let us I'll show you the another way of running the code. Why? Because if you are running the code from this, ideally that displaying parameter or displaying the output or accuracy or epoch processing, that looks very horrible. Okay, so that's why I'm going to show another way. Okay, so please type command prompt. Okay, so just open the command prompt and then copy the file location of where your code lies. Okay, so and then type cd and paste the location and press enter. So still now it is gone, it doesn't go into the location. So I'm typing the drive, specifically drive : and then enter. So we are in the directory. Okay, now I'm going to type the command called python space train.py, enter. Okay, now we're going to start the training. So it is giving some kind of warning like cudart64_101.dll not found. So this is especially for GPU based laptop. So since here I'm just having only AMD graphics card, so it is skipping that you don't have that GPU on that machine. Okay, so it's just skipping, so don't bother about this warning. You can run the code from your normal laptop itself. Okay, it start training. So epoch 1, 2, 3, 4 and then 5, it shows accuracy is 65.62. Okay, and also it displays saved model to the disk. Okay, so accuracy is 0.6107 and it is getting increased like 0.62, 0.65, 0.64, 0.6497 and 0.65. Still it is increasing. Please try to change your epoch and try your code. Okay, so definitely you'll get a very good accuracy. Okay, now we'll check in our directory. So we got two files. One is model.json and another one is model.h file. Okay, it represents that it has completed the training for 5 epoch and it saved the model in my local directory in the name of model.json and model.h file. Okay, now we are going into the testing part. Okay, recent files, and I'm going to take test.py. Okay, so on the test.py here I don't have reference data or test data. Okay, what I'm going to do is I'm going to do the testing for every rows which is present in the same Excel file. but I'm not going to take the final column. Instead of that, I'm going to take that certain part of column, and I'm going to do that testing for complete rows which is present in the complete Excel file. Okay, so that's the thing I'm going to do. So for that, same syntax I have loaded before, so same libraries and same procedure to load a data set, and then with the syntax called loading the file or loading the model, I'm using the same syntax which I have seen in the PowerPoint presentation. And the new syntax which we are going to see here is prediction is equal to model.predict underscore classes of parameter x. Why I am passing x variable here? Because x only contains that 8 columns. Okay, like first 2, 3, except that final column, that 8 it contains inside that x. Okay, so that's why we are using x here. Okay, and then don't get scared about by seeing this line. This line is nothing but it will display the predicted result, and also it will display the proper result which is present in the Excel. Okay, so that we will compare whether our model classified or recognized that output value properly or not. So definitely the value will be either 1 or 0. 1 resembles that is diabetic presence, and 0 resembles that is diabetic absence. Okay, so it will identify that. Okay, so here print of this value. So here we're going to compare it with that. Okay, so of x of that parameter, x of I resembles that. Here we are going to take parameter of 5, 10. Like I'm going to take Excel file of 5th row. Okay, so like I'm going to take this one, this two, sorry. So I'm going to take like this. Okay, so I'm going to take this 5 rows, and I'm going to predict either I'll get 0, 1, 0, 1, 1. Okay, I'm going to check whether I'm getting this value or not. Okay, so let us run the code. Python that is test.py. Okay, so now it printed an output. So in that output, first of all, it processed the first row. First row means that is 5, 1, 1, 6, 7, 4, and this row. For this row, the output should be 0, right? But what we got 0, perfect output. Okay, so first row we got the perfect output. Okay, even though we only have that 64% accuracy, we got the perfect output for the first row, right? So let us take a second row. 3, 78, 50, 32, 88. For that row, what output we should get? Number 1. So that resembles that presence of diabetes. But what we got 0. That is misclassification, right? So expected 1. So expected 1, but we got only 0, right? So it is misclassification. And let us take a third row. That is 0. Okay. So if we got 0, expected is 0. That's proper. So and then we'll take further rows. So expected 1, we got expected 1. So only, I think it's up to only 2 misclassifications, right? So definitely it will get better classification while we trained for more epochs. So since it will take some more time, so since we are getting times out, right? So on that scenario, we are going to process it with the more number of epoch. Okay, so that's the main thing. I hope you all got that basic about training and then testing, right? So those source code which is given in here. So definitely, and other thing I would like to say is join with us on 30-day challenge, guys. So this up to took 1 hour and 10 minutes, right? This live. So apart from that agenda and introduction and giving greetings, so other than that, that's up to 1 hour and 10 minutes, right? But in the internship portal, we gave up to 1 hour and 20 minutes without any introduction, without any other thing. Okay, so please go to that internship portal. Okay, there you will get detailed explanation other than that. So like Bragg propagation and that loss which is done for gradient and a method called gradient descent method. So those details is given in the internship portal. I hope you'll get it. Okay, so please join with us in 30-day challenge. So on the 30-day challenge, we are going to see that computer vision, machine learning, deep learning, and natural language processing. So that you will get a recorded video lecture for 30 days. So even you have missed the first video, which is creating a chatbot, that is very interesting. You might missed that. So that includes also that each and every sessions. and also you'll get complete source code of 25 projects, even though this code, and not only this. So for the upcoming session, we are going to have a detailed codes up to 200 lines or 150 lines of code. So for 25 projects up to now. So that source code you can't able to copy from that presentation or the source code, right? So you can get it from there. And then PowerPoint presentation. So each and every slides with diagrammatic representation. So those slides you will get it from there. And we will also have 60 days accessibility. And also you'll have that forum support. So here a lot of people are trying to interact with me on LinkedIn, but LinkedIn getting a little bit difficult for me to handle, because I hope you all understand, like same people are asking the same question for up to like 20 to 50 people are asking the same question, so multiple times. So that looks very difficult for me. I'm really sorry for that. I'll try to answer you still now. Okay, so don't mistake me. Okay, so that, but if you are in internship forum, so there you can get that kind of support where each and every question get answered. So that answer you can refer and you can correct your mistakes. And then flexible timing, like a Udemy course, you can able to check or you can able to see each and every course. Okay, and then you will also get internship certificate, and this complete course or this complete course will cost you only 750 rupees. So if you have seen lot of course, you may check it out. I'll give you the challenge, okay, that especially on artificial intelligence. So there we are charging up to 50,000 or 40,000, and even up to like 25,000. Definitely it is a very great chance to have the complete course on 750. And also we are giving detailed explanation on computer vision, machine learning and deep learning, as well as in the natural language processing. And also we have converted, or we have changed that way of presentation in kind of application based learning. So that's why this agenda is segregated into each and every projects. Okay, so that's the main thing. So internship portal where you can get that learn.pantechsolutions.net. Okay, so where you can see in here. Okay, so it contains kind of Udemy kind of thing. Okay, so where you can see each and every course, it's assignments and then attachments. Okay, so if you see here that the day 10, so that is 18 minutes, and then 24 minutes, and then 15 minutes and 22 minutes. It's approx 1 hour and 20 minutes of video we have already released for you for the assignment, for the intern guys. So just please check it out. Okay, so still there that the MATLAB masterclass and brain computer interface masterclass are there. You can, if you want, you can check it out. So don't get scared about by seeing the price. So due to this quarantine, we are offering it for very low cost, up to 500 and then 750. So for artificial intelligence, it's 750. So please check it out. Okay, so AI news of day 9. Actually yesterday we have missed the artificial intelligence news, right? So in China, they are using deep learning to predict the critical COVID-19 cases by studying the medical image. Okay, actually they have tested about 1590 patients from 575 medical centers across China. This data is occurred, this data is obtained on July, but since a lot of months are gone away, right? So definitely they have tested for a lot of cases with the help of this artificial intelligence, especially with the help of deep learning. Okay, so this is the AI news of day 9. And today's AI news. So robot swarm, which follows instruction to create a art. So for example, what is meant by swarm robots means tiny lot of robots going to do a single task by having some kind of instruction. So that is kind of swarm robots. So here you have, you can able to see there are up to 10 to 12 swarm robots are doing a single art by having some kind of instructions to do. With the help of artificial intelligence, it's performing its own art. I think it's very interesting, right? So like Intel has also deployed hundreds of thousands of drones in their air to display as an Intel logo. So like they are flying up the drones with the help of artificial intelligence. So it is very helpful. Definitely going to play some major role in upcoming technologies. So this news is on this month. Okay, so I hope you all like this news. Okay, so we are in the question and answer session. I hope some of the people have exhausted. If you are exhausted, please type yes. If you are not exhausted, you please type no. Okay, I am excited to see your answers. So other than that, you can ask your technical questions. So still we are running out of time. So please ask your technical question as soon as possible. We can also use tf.keras models or tf.keras layers, since now TensorFlow onwards, Keras is a sub-library of TensorFlow. Yes, we can use TensorFlow as well as Keras. Definitely you can. For 750, are you giving videos? We are not going to deliver, or we are not going to send the videos to you. Instead, I'll give you, or our Pantech team will give you the access for this portal. Okay, so in this portal you can able to see each and every course. Okay, so each and every course videos will be placed here, and if you're going into the assignment section also, you can be able to see that. Okay, like a masterclass, so PowerPoint presentation, and then source code for that specific presentation. Okay, so let us see in this here. So it will give you that source code as well as our presentation, and here there are assignments a lot of people have completed with their screenshots. So Archana, Dharma, so like that we'll have this portal. So we will give you the access for this portal where you can able to get, or we can able to see each and every videos. Okay. My command is not opening when run as administrator. That is up to your laptop. Please check, try to open in a normal mode. Okay. So will you share PPTs? So PPTs will be available for intent participants. Okay. So those who have accepted our 30-day challenge. Why? Because this 30-day going to change, maybe change your life, because whenever you are doing something for 30 days or 40 days, it will going to be turned into your habit. So on that way, so we are changing, or we are making this learning as your habit. So even though we are taking for Sundays and we are taking for Saturdays also, so definitely it will going to change your lifestyle. Okay, so that's our main motive. If image size is different, that is based on your model. So for example, here we have started from the scratch, right? So if you are taking any pre-trained model like ImageNet SSD or VGG16 or VGG18 from the Keras means, so each and every model will have some kind of prerequisite. So for example, if you take VGG16, if its input size requirement is 24x24 means you have to do the pre-processing of an image to convert that image into 24x24, and you have to pass into that layers or neural network. Okay, so each and every neural network has its own prerequisite of input image. So that is known as a pre-processing, where you need to deploy some kind of operation for an input image which we are going to pass over. Okay, if I how can process image data set? Yeah, that same which we are going to see in the upcoming session, don't worry. So since it is a basic neural network design, that's why I have created it for normal data set. Okay, so we'll see it in the image as well. My final year project based on diabetic retinopathy through fundus images, and how I implement automatic system for detection of DR using deep learning. Yes, of course you can do that. You just want to check it out your medical image, what the format of medical image, and you have to choose a specific deep learning model, or you can go for learning called transfer learning. Those learning will see in the upcoming sessions. So those things we'll see in the upcoming sessions. What is artificial intelligence? Great question. So please connect with me on internship portal, specially made for you. Okay, so please, if you have missed this, it seems that you have missed a lot of sessions. So please connect with us through this internship portal, where you can able to see this artificial intelligence and application and creating your chatbot. So it will be very interesting. So if you have paid a fees, definitely they will contact you. So contact or everything you have already, right, while filling up the attendance form. So where you can contact them to give you the access. So definitely they will give the access within 12 hours. Okay. After this course, will there be a Raspberry Pi course or Arduino course? Definitely, Anupam. We are going to have Raspberry Pi as well as Arduino after Diwali, I think so. Okay, definitely we'll have. If we have participated today in intent, then we will miss 10-day assignment. No problem. Definitely the assignments are there. You can fill up your assignments. So that is for your practice only. Okay, so you just check it out, each and every assignment. That is for kind of practices only. So you just go through each and every videos. Why? Because this deep learning, no, within this 1 hour you can't be able to get. So you have to have a repeated listening of that video. So on that scenario, this intent portal will be very helpful. Okay. Where is the internship portal? So that link is given in our description, guys. You can check it out. Where you have to register, you have to pay for it. So that's a premium thing. Actually, we have two kind of course plan. That is, one is YouTube. So even YouTube also you can able to learn, but only thing it becomes a little bit difficult. Why? Because in this internship portal we have given some kind of bonus sessions also, like using some kind of color tuning based HSV value. That on that only in YouTube we are seeing only a demo video, not a source code and all. But source code is given in the internship portal. And to use your Android mobile phone camera for image processing application. So each and everything is given as a bonus for internship participants. So you can check it out and you can join it there. So we can divide the data set of 2000 image examples into batches of 500. Then it will take 4 iterations to complete one epoch. Yes. Not able to install PyTorch, throw an error like could not found the latest version. Please check your Python. If you can't able to do that, please find out the specific version of Torch which supports your Python version. Okay. So if it's suppose 1.1.3 means you just specify its version with the help of pip install Torch double equal to and specify its version so that you can able to install it. I can't attend previous session. What can I do? Still there. The video is present in the YouTube. You can check it out. You can attend the session. Great session, but time is not much enough for today's topic. If possible, split it for 2 days. Actually, the agenda, Abhishek, it's great. Agenda is already framed. Okay, so if you have changed that, it will definitely going to collapse complete 30 days. So that's why we have not segregated. So still now we have given a complete explanation on internship portal where you can able to check it out. Okay. So with the Q&A in everything we are going to complete for 1 hour and 20 minutes. But without that basic intro and every such kind of basic thing, the video which we have uploaded in this internship portal, that's up to 1 hour and 20 minutes. So I hope we have got some kind of knowledge. How can I integrate the Dialogflow chatbot with the website made in Django? Those things we have to check for that integration part which is present in the Dialogflow option. So please check it once. If possible, I'll try to drop that. Okay. What are the best boards rather than Raspberry Pi to work with Python program? My suggestion is to use NVIDIA's boards. So if you are if you can able to afford a lot of money, so you can purchase NVIDIA Jetson Nano, and even it is a little bit low cost when compared to other NVIDIA boards. Like if you have purchased like Tegra or something like that kind of board, it will cost you like 1.5 lakhs or 1.25 lakhs. And also some other version like 80,000. So instead, if you are getting the NVIDIA Jetson Nano, that's up to 12,000. Okay, so that will be very helpful. Okay. Okay, I hope we got basic information about it. So still time is running out. I hope a lot of people have exhausted. So okay, so thank you so much for attending this session, guys. So if you are an internship participant, and if you are that 30-day challenge accepted participant, you just please check it out, the internship portal where we have described little bit concept in detail. Okay, just please check it once. Okay. So just here I have a quick overview. So there you can able to identify this slide is not present in the YouTube. Okay, so on the time you have a more attention on that specific video lecture. Okay, so that will be very helpful, guys. So please don't miss it, and have a practice by yourself, and post your assignments in the internship portal where the assignment is like to have a more epoch, like 150 epoch drop 150 epoch. I'll attach the presentation and source code now. Okay, so you just start the training and post your output of accuracy which you got, and what epoch you have used, and then do the testing, and you just post your output, how much accuracy you got. Okay, so and thank you so much, guys. So if you want to connect with me personally, you can contact with me through LinkedIn, the link which is given in the description. Okay, so if you have any technical question, please interact with me on YouTube comment. Okay, So if you are an internship participant, please raise your questions with the error in the internship, and especially today becomes a little bit difficult to handle that forum. So definitely before tomorrow I'll answer the questions which you are raised in the internship portal. Okay, and thank you so much for attending this session, guys. So tomorrow we are going to see object recognition with the help of pre-trained model. Okay, I hope you all excited. So please make your laptop and your camera be ready to deploy application of object recognition in real time. Okay, and thank you so much, guys, for attending the session. I hope you all got some basic knowledge about CNN architecture and basic functionality and how to design a basic neural network. I hope you enjoyed it, and thank you so much for this interactive, guys, because a lot of people have interacted with me. Okay, so thank you so much, guys. So, and someone is saying, hey, don't go, please give some reply to my questions. So please raise your question. I can't able to find Shashi Prabha. What's your question? Shashi Prabha, I can't able to find your question. Sorry. So once the session is completed, you can raise your questions in the comment box, Shashi Prabha. Okay. So thank you for your interaction, guys. So we'll see you on tomorrow's session. So that's it. Until then, bye.